हेलो एवरीवन, नमस्कार। तो आज हम एक और क्वेश्चन सॉल्व करेंगे फूरियर सीरीज से। सो वी हैव टू एक्सपैंड द फंक्शन एफ एक्स इक्वल्स टू एक्स साइन एक्स एज अ फूरियर सीरीज इन द इंटरवल माइनस पाई टू पाई and deduce that 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 5 into 7 so on is pi minus 2 by 4. फर्स्ट फोकस विल बी टू फाइंड द फूरियर सीरीज। तो स्टार्ट करते हैं उसके साथ। तो हमारे पास एफ एक्स क्या गिवन है? एफ एक्स इज योर एक्स साइन एक्स। फर्स्ट ऑफ ऑल चेक वेदर दिस इज इवन और ऑड। So for that find f of minus x. So put minus x in place of x in both the places. So sine of minus sine x, sine of minus x is minus sine x, so minus minus plus, so you finally get x sine x. Now this is your f of minus x, so you are getting your f of minus x to be equal to f of sine x, f of x only. That means this is an even function, and in case of an even function हमारे पास जो bn होता है वो जीरो होता है। ठीक है, तो हम एक्सप्रेशन अब क्या लिख पाएंगे एफ एक्स के फूरियर सीरीज के लिए? एफ ऑफ एक्स बराबर ए नॉट बाई टू प्लस समेशन n इक्वल्स टू 1 to infinity an cos nx, because bn is 0, so no further terms. Now let's start with finding a naught. So a naught will be, since the interval is minus pi to pi, so we know in expression of a naught, an and bn, all three 1 by pi will come and integration will be from minus pi to pi. So 1 by pi will be outside, fx dx. So fx is your x sin x dx. Now because whatever is inside is an even function, so we can write minus pi to pi as 2 times 0 to pi x sin x dx. This one is the first function, this one is your second function. Now a naught is 2 by pi, first function as it is. Integration of sine x is minus cos x minus integration of derivative of first function. So derivative of x with respect to x is 1 into integration of sine x, which will be minus cos x. Moves from 0 to pi. So your a naught will be 2 by pi minus x cos x. Integration of cos x is sin x. Now put pi So you will get 2 by pi. Cos pi is -1 into minus pi, so you get pi. Sin pi is 0. Again, if you put x as 0, so this will be 0, sin 0 is 0, so only this term. So an you are getting as 2. Sorry, a naught. Coming to an, so that will be again 1 by pi minus pi to pi fx into cos nx. Okay, so fx is x sin x into cos nx. Now here you have got product of 3 functions. Okay, so first of all what I will do is to convert this into product of 2 functions. Okay, so I will try to find something which can simplify this sine cos. So I know that sine of a plus b is sin a cos b plus cos a sin b sin of a minus b sin a cos b minus cos a sin b. If you add this to, because you want to keep sin a cos b type term alive, so just add them. So you get sin of a plus b plus sin of a minus b equals to 2 times sin a cos b, so divided by 2 equals to sin a cos b. So I will use this expression in my given integral. So I can write this as an equals to 1 by pi, and now this is minus pi to pi, and this is x will remain as it is. Sin x cos nx I can write as sin of x plus nx, so that can be written as n plus 1 into x plus sin of x minus nx, so sin of 1 minus n into x divided by 2. 2 I can take out, also sin 1 minus n I can take minus sign out, because sine of minus theta is minus sine theta. And also if I can separate this, here 2 will be in denominator, so I am separating integrals now. So 2 by pi x sine n plus 1 x, okay, minus 2 by pi minus pi to pi sine n minus 1 x, sorry, x sine n minus 1 x dx in both the cases. Now I will solve them separately, so I am writing an as I1 plus I2 Let's solve them separately and then we'll come back to the an expression. So an, first solve I1, which is 2 by pi minus pi to pi, but because x sine n plus 1x, what do you want to say about that? That is an even function. Okay, so because that is an even function, we can write 0 to pi, and 1 2 will come out because of the even function. So this will become 4 by pi x sine this becomes your first function, this becomes your second function. So I is 4 by pi, first function as it is, integration of sine is minus cos n plus 1 x divided by n plus 1 minus integration of derivative of x is 1, integration of sine again is minus cos n plus 1 x divided by n plus 1 whole integration from 0 to pi. I will be 4 by pi minus x cos n plus 1 x divided by n plus 1, integration of cos is sine divided by whatever is with x. So 1 n plus 1 was already there, so this will become n plus 1 whole square, 0 to pi. Now I will be, if you put pi here, so this will be minus pi cos n plus 1 pi will be minus 1 power n plus 1 divided by this n plus 1. Sin n plus 1 pi will be 0. Again, if you put 0, first term will become 0 because of x, second term will become 0 because we have sin 0. So you will get this expression only, cancel out pi. So you are getting I1, this is nothing but I1 we are solving. So you got I1 as 4, rather minus 4 minus 1 power n plus 1 divided by n plus 1. Okay. Again, one thing which I have done wrong is when you take this 2 out, this will become, I am talking of this 2, so this will come in denominator. Again I have taken that in numerator, so that's one mistake which I have done. So let's correct that. So it will be 1 by 2 pi both place. So 1 by 2 pi and 1 2 came because of the even. So 2 2 cancel, only 1 by pi will be left. Now this step pi cancels out, so you are finally left with what? Minus of this. Okay, coming to the next integral, which is I2. So I2 was minus 1 by 2 pi x sine n minus 1. Again, because x sine n minus 1x is a even function, so 2 comes out, this becomes 0 to pi x sine this 2 gets cancelled. This is, we can treat as first, this as second function. So I2 is minus 1 by pi first function as it is. Integration of sine is minus cos n plus 1, sorry, n minus 1x divided by n minus 1, minus integration of derivative of x is 1, integration of sine again cos, whole integration moves from 0 to pi. I2 is हमारे पास यहाँ पे माइनस 1 बाई पाई है, ठीक है, माइनस एक्स कॉस n minus 1x divided by n minus 1. Integration of cos is sine, so sine of n minus 1x divided by another n minus 1, so n minus 1 square. Moves all the way from 0 to pi. So I2 will be, when you put pi, first term will be minus pi, cos n minus 1 pi is minus 1 power n minus 1. This denominator n minus 1 remains as it is. Sine n minus 1 pi is 0. Again, if you put 0, first term will be 0 because of x and second term will be 0 because of sine 0. So we can cancel this out. Minus minus is plus. So I2 you are getting as minus 1 power n minus 1 divided by n minus 1. So we can write the expression for an finally as I1 plus I2. So your an is, what was your I1? Minus 1 power n plus 1 divided by n plus 1. And what about I2? That is minus 1 power n minus 1. Now an is, we can take minus 1 power n common. So you are left with minus sign and minus 1 power 1, which is minus 1 only. So you get plus 1 here. Here minus 1 power n you took common, and you are left with minus 1 power minus 1, which is also minus 1 only. So minus 1 upon n minus 1. So your an is, this becomes n square minus 1, n minus 1 minus n minus 1. So n gets cancelled, we are left with minus 2. So an is minus 1 power n and minus 2 divided by n square minus 1. One thing you will notice that this expression of an is not defined at n equals to 1, because if you put n equals to 1, denominator becomes 0, so this becomes not defined. So what we'll do, while writing the Fourier series, summation is n equals to 1 to infinity an cos nx. So that summation we can shift from 2 2 to infinity rather than 1 to infinity, because at 1 this expression is not valid. So we need separate expression a1. How will we find this separate expression for a n equals to 1? Come back and come back to this step. Which step? This particular step. Now here, if you want to find a1, put n equals to 1. So this sine 1 minus n term will get cancelled, because that will be 0, because sine 0 is 0. Only thing you are left with x sine 2x, okay, and this 2. So 1 by 2 pi x sine 2x, okay. That's the only thing you are left with. 1 by 2 pi x sine 2x. X sine 2x. Because again, this will be your even function. So we can write 0 to pi, and 2 comes outside, which cancels with this 2. First function, second function. First function as it is, integration of sine is minus cos, minus derivative of x is 1, integration of sine is again minus cos, whole integration moves from 0 to pi. So your a1 will be 1 by pi minus x cos 2x divided by 2. Integration of cos is sine, divided by 1 more 2, so 4, from 0 to pi. When you put pi, so cos 2 pi is 1, so you are going to get cos 2 pi is 1, so minus pi by 2. Here if you put pi, sine 2 pi is 0. When put x, first term will become 0 because of x, second term will become 0 because of sine 0. So a1 you are getting as minus 1 by 2. So I can now write my Fourier series, which is fx, and fx was your x sine x. This is a0 by 2. What was our a0? a0 was 2, so 2 by 2 is 1. Plus a1 cos x will also come, because we'll start the summation from 2 to infinity. So for n equals to 1, a1 will come. So that is minus half multiplied by cos x. Multiplied by cos x or cos nx. But here you see, because we'll put n equals to what? 1, so this will be cos x only. Plus summation, what was that term? Minus 2 minus 1 power n divided by n square minus 1. This was the expression, I think. Now this moves from 2 to infinity, and for n equals to 1, this expression. So that's it. This all we have for this Fourier series. Now ultimately we had to find one more thing, which was 1 into 3 minus 1 upon 3 into 5. Okay, so we had to prove that this is pi minus 2 by 4. Okay, so let's start how we can do. If you put 0 both sides, what will happen is that summation entire term will become 0, because cos 0 is 1. So will that entire thing become 0? I don't think so. If you put cos 0 as, if you put 0 both sides, let's check. So LHS is definitely going to become 0, equals to 1. Here cos 0 is 1 minus 2 times. Here if you put 0, so this will become summation n equals to 2 to infinity now. If you start this 1 minus half is half only, so this will go to that side as minus half. Okay, and minus half equals to, if you start putting the values, so for n equals to 2, this will become 1 upon 4 minus 1, which is 3. Now this n square minus 1, for some time I can write this as in this form, n plus 1 n minus 1. So 2 plus 1 is 3 and 2 minus 1 is 1. Okay, what will be my second term? I will get that by putting n equals to 3, so that will be minus 1 upon 3 plus 1 4 and 3 minus 1 is 2. Okay, so definitely as you can see, I am getting 1 into 3, but as a second term I am getting somewhat different, 4 into 2. So this is not valid. Okay, so I will have to try for another value. Let's check for pi. So what will happen with pi? Again LHS will become 0, 1. Here you will get 1 plus 1 by 2. Cos n pi is minus 1 power n. Okay, let's check for pi also. I don't know for which value it is going to hit. So 4 x equals to pi entire LHS is 0, 1. For pi, cos minus pi, pi is minus 1 minus minus plus, so it will be 1 by 2 minus 2 summation n equals to minus 1 power n is already there, minus 1 power n will another come because of cos n pi. So minus 1 power n into minus 1 power n is minus 1 power 2n. Fine. Now This is 1 plus 1 by 2, 3 by 2, that will go to that side. Put n equals to 2, so minus 1 power 4, that is 1 divided by 3 into 1. Okay, when you will put the value of n as 3, so minus 1 power 6, that will again be positive. So as you can see that this will always be positive, because minus 1 power 2n is there and n is 2, 3, 4, 5 and so on. So this will always contain positive terms, and if you are thinking this minus sign will come, so both terms will be negative, all the terms will be negative if you take minus sign inside. So this is also not working. I am leaving this incomplete because this is of no use to us now. Now thinking of some other values, 0 we have thought, pi we have thought. Let's move on to x equals to pi by 2. So sine pi by 2 is 1, so pi by 2 into 1. So LHS you are getting pi by 2 equals to 1. Again cos pi by 2 is 0, so second term cancels out. Minus 2 minus 1 power n and cos n pi by 2, right? So when you put x here, so this will become n pi by 2. N pi by 2 divided by the same n plus 1 and n minus 1. Now again I will start putting the values. So pi by 2 equals to 1 minus 2 times. When you will put n equals to 2, this is 1. This is 1 upon 3 into 1. Cos, when you will put n equals to 2, this will be 2 cancel, cos pi, which is, what is cos pi? Cos pi is minus 1, so this you will get minus 1. Second term, n equals to 3, so minus 1, 3 plus 1, 4, 3 minus 1 is, sorry, yes, you will put n equals to 3, so 3 plus 1 is 4 and 3 minus 1 is 2. Okay, wait, I was getting the same expression before also, so why I cancel that? So when you will put n equals to 3, you will get 4 and 2. Okay, there was nothing as there, so there was no scope here. As you can see, when you put n equals to 3, you will get cos of 3 pi by 2. Okay, so you have to see this carefully, cos of 3 pi by 2. Fine. So cos pi by 2 0, cos 3 pi by 2 again 0. So whenever you see the odd multiple of pi by 2, you are going to get 0. Okay, pi by 2, for pi by 2 it is 0, for 3 pi by 2 it is 0, and that's it. Okay, so so this will become 0. For third term, put n equals to 4, so you will get 1 by sorry 1. When you will put n as 4, so 4 pi by 2, that is 2 pi, cos 2 pi is 1, 2 plus 1 3, sorry, that will be 4 plus 1 5, and 4 minus 1 is your 3. Okay, so this is your second term. Let's write two more terms so that we get a clear idea. This video is becoming a bit lengthy, but yes, we are analyzing. So when you will put n equals to 5, so again this minus sign will come, cos 5 pi by 2, so that is 0, because again odd multiple of pi by 2, and here whatever will be there, for 5 it will be 6 into 4, so it doesn't matter because it is going to become 0. Now if you put n equals to 6 minus 1 power 6, so that is 1, 6 pi by 2, so cos 3 pi, so cos 3 pi you all know is, that will again come minus 1, okay, divided by 7 into 5. Okay, now as you can see, first term will come, second term anyway going to become 0, this term is again going to become 0. First term came negative, then positive, then negative, so after that 0, the term will, which will become 0 will come. After that again a positive term will come. Can we write that? 1 upon 3, 1 into 3, 3 into 5, 5 into 7, 7 into 9, minus dot dot dot. What we have to prove? 1 into 3 minus 3 into 5. So I can take that minus 2, so minus I can take inside. So I am getting pi by 2 equals to 1 plus 2 times 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 5 into 7 minus so on. What's the problem now? Problem is there, you want to get only this expression, so everything else you have to get rid of. So pi by 2 minus 1, and also divide this by 2, so whatever is in the RHS is your required expression. So you are getting pi minus 2 divided by 4. I think this was only needed, is 1 upon 1 into 3 minus 1 upon 3 into 5 . That's it. So a bit lengthy question, but something new we got to find, that if in the expression of an is not defined or bn is not defined for some value of n, and if that is the initial value, that is, let's say in this case that was 1, so we find for 1 separately and start the summation from 2 to infinity. Okay, that was something new we learned. and also how to put pi by 2 and get to our answer. And when x sin x cos x was there, we used some trigonometry also. That's it. I think you enjoyed it, learned something from the video. It was a bit lengthy, but we analyzed it properly. Thanks and have a nice day. Do subscribe this channel. I hope you learned. Do watch the playlist on Fourier's series as well for more such videos. Thanks again.